Right. So thanks for being here. And this session is going to be about the sign test and how you can use it in your intro stat course. And I'm going to go over some different times you can bring this into your course. And I'm going to start off by talking about exactly what the sign test is. So the most important reason for bringing in the sign test is that it does give you a chance to give an alternative test for your students to use when the conditions for the one mean test are not satisfied. So whether there's an outlier, the data are not normally distributed, whatever goes wrong, we spent a lot of time talking about, hey, you got to check those conditions. You got to make sure that this test is applicable. We don't really offer anything to do when these conditions aren't met. So this is a good way to do that. It's a really easy test for students to understand logically. And I'll show you how that works in a moment. So it's not above your students. I think a powerful weapon for incorporating this is that you can bring it in really early in the semester. And I'm going to kind of work chronologically backwards. I'm going to talk about how I use it at the end of the course, but then I'm going to also talk about how you can bring it in during the, when you're talking about binomial probabilities, as well as when we're talking about measures of central tendency, like when we introduce the median, we can bring it up then. I've got a sample problem that I'm going to use as my starting point. This is the mean wait time at a drive-through of a fast food restaurant is 90 seconds. A new system is implemented to reduce the wait time. I've got the times listed. And so if we're trying to show that the wait time has decreased, right, as we reduce this, we're testing a null hypothesis that the mean is 90 seconds versus an alternative hypothesis that the mean is now below 90 seconds. Right? So this is a standard one mean kind of test. And what we're supposed to do first is check the conditions. Are there any outliers? Do the data come from a distribution that's normally distributed, a population, I mean. And so I've got this data loaded into StatCrunch. The 10 values are here. And so I would just do the regular t-test for one mean, pull in the data, set the mean equal to 90 versus less than 90. And I can check the conditions at the same time by going from box plot down, adding those in. And when I get these results, the normality actually checks out, but there's an outlier in this set of data. The first value, 115 seconds, is an outlier. That tells us that we're not supposed to use this test. And so at that point, if we don't use the sign test, we have to tell our students, you just can't do this test and you move on to a different kind of problem. But if you introduce the sign test, we can actually do a similar test for this data. And so that test is the sign test. It's a test for a population median. So it's comparing the median to 90 rather than the mean. And the idea of the calculations are actually pretty simple. We go through the set of data and we're going to put a plus sign for every value that's greater than the median. We're going to put a minus sign for every value that's below it. And we're just going to cross out any values that are equal to the median. Once we've totaled the positive signs and the negative signs, the plus signs and the minus signs, we know that if that 90 really is the median, half the values are supposed to be below and half are supposed to be above. So the chance that a value is below or above is 50-50. So we can do a binomial probability calculation at that point. So bringing the data back up, again, we're comparing this to 90. So 115 is above 90. That would be a plus sign. The only other value that's above 90 in this problem is the 96. All the others are below 90, and so they would get minus signs. So we have 2 positive signs or 2 plus signs and 8 negative signs. I can now do a binomial calculation where the sample size is 10 because I didn't cross out any values. There were no 90s in the list. The probability that it's below 90, any single value is below 90 is 0.5. And what we want to find the probability of is that we have 8 or fewer negative signs. And I'll actually show you that with the binomial calculator. Stat, calculators, binomial. N is 10, P is 0.5, that's good to go. And I just need to find greater than or equal to 8 of these negative signs. And I can see that probability that I get as a result, that's the p-value for this test. So here, p-value is 0.0547. So if you were doing a 0.05 level test, you'd say there's not sufficient evidence to support that the median is below 90, but at least now we could come up with some kind of a conclusion. Even though we're not testing the mean versus 90, we can still test this median versus 90. This test can also be done directly in StatCrunch. So I like to go through and show the students one time by hand how to do this. And then I would follow up with this built-in test in StatCrunch, where you type all the values in a column. And the test is under the nonparametrics menu. Stat, nonparametrics, sign test. Pick the column just like before, enter the value in HO just like before, and reset the sign for H1. And there you go. You can see the p-value is just what we had with the binomial calculation. There were 8 below, 2 above, and the chances of that happening or something more extreme, 0.0547. So once I introduce it one time by actually writing the plus and minus signs and so on, then I show my students how to do this. And if you cover the one mean test on, say, Monday in class, you can come back and review a couple of examples and then introduce this really quickly. And once you've done some of these alternative tests, your students will pick up on it from day to day a lot faster as well. Now, in my remote setting, this is how I use this test. I introduce it after the one mean test, but it actually can be incorporated a lot earlier in the course. You can bring it up when you cover probability distributions because it's just a nice application of the binomial distribution. And you can even introduce it really early when you introduce measures of central tendency. All your students have to understand is what a median is and what that represents, half the values above, half below. And then you can incorporate this in. I'm going to show you, I'm going to finish by showing you how we can do this way back at the beginning of the course. And that can be done by using coin flipping. And again, I would do this once by hand and then a second time with StatCrunch. You take a coin, you assume it's fair, and we'll let heads represent the ones that are below the median and tails will be the ones above. The heads are always the ones that you want to count. For a left tail test, you want to count the minus signs. For a right tail test, you want to calculate the positive signs. Have everybody take out a coin and flip it 10 times and count how many heads they get. So then out of your classroom full of students, then you want to ask them how many of you had at least 8 heads. That is an estimate of the p-value for this test. Now with your small sample size, if your class has say 30 students, that's probably not enough times to flip the coin 10 times. But we don't want our students flipping coin 10 times, maybe 1,000 times in class. So we can speed this up inside of StatCrunch. The goal here, since we haven't talked about p-values at that part of the course, if anything happens less than 5% of the time, that's what we label as unusual. So if you see 8 or more heads less than 5% of the time, that's an unusual event, and that suggests that the median actually is lower than 90. So StatCrunch has a built-in app for that. There's others, by the way, online that you can use. You don't have to use StatCrunch to do this, but you can build a simulation of coin flipping where we'll flip a coin 10 times, thousands and thousands of times for you, and count how many times you get 8 or more heads. So let me show you what that looks like. And you'll notice, right, our p-value from before was 0.0547. We're going to be close to that with the coin flipping as well. That is under, and by the way, I'll drop the PowerPoint presentation into the chat so that you can have a copy of this with all the directions. It's under applets, simulation, coin flipping. Yeah, same idea. That's right. Probability of heads is 0.5. Number of coins is 10. And I wanted to count how many times it gets 8 or more. So I press compute and that builds the applet. And then I'd like to have my students do it 10,000 times. And so they do that by pressing 1,000 runs 10 different times. And the value up at the top right where it says proportion, that's your estimate of the p-value. So here we would have 0.0587, which is still not below 5%. So we wouldn't consider this unusual. That means that we don't have enough evidence to say the median is below 90. I did one earlier and copied it onto my presentation. I got 0.0517. It was always between 0.05 and 0.06 when I did it. So that's the short introduction to the sign test. Again, I do think that it's a really easy test for students to grasp, right? They can figure out, is this above or below? If they understand the median, they know that half the values are lower than the median, half are higher. So they understand if that 90 was really right, each number has a 50% chance of being below 90. So that's accessible. And finally, when you get to the end of the course and you're doing that one mean test, you're giving your students an option for things to, for a backup plan when the conditions go wrong. And I think it's a good idea to do backup tests for all of your tests that have conditions, not just the one mean, but one proportion. You can use the binomial distribution. Any of the mean tests, there are non-parametric alternatives, and even something like the 2 proportion test, you can use a randomization style test to do that. I've got my contact info on the screen in case there's anything that, any questions that you have. I will drop that PowerPoint, like I mentioned, into the chat in case you want to have a copy of that. That's on its way. And I know that was a little quick, but Ted, do you have any comments or questions for me? Yeah, you bet.
Well, no, this looks really good. I've never seen this before. I've heard of it somewhere, but
yeah, I think it's a really, powerful thing to include in the class. We were speaking before the session started about the idea of you don't want students to think that, oh, just calculating the mean and the median, that's the idea of the course. When they're early in the course, you want them to have their eyes on the prize long-term, which is inference. And so it's kind of a nice way to bring in the inferential concepts without those ideas of how do we calculate a p-value? What's the level of significance? We don't have to talk about any of the jargon, but we can still get those ideas out there for our students.
Yeah, I really like that idea. I saw this presentation a long time ago with the dolphins, the Buzz and the Doris dolphins, and they were,
Yeah, yeah, yeah,
this is very similar with the coin toss. Yeah, so
yeah.
I'm actually teaching stats right now, so I think I'll use this.
Yeah.
Yeah,
And you know, Ted, if you have, I know I've got some blog posts about that on my stat blog. And so if you go to that blog and you just search for sign test, I'll
okay,
talk a little more detail about the kind of things I do to introduce it into the class. And I do think that there's a couple of examples that are there that you can download and use as well.
wow, okay, great.
Awesome. Well, thanks for being here. I do appreciate it.
I was just going to ask you one last question.
Yeah, you
George,
bet.
did you ever make a presentation in AMATC about discovery process,
Like discovery learning.
discovery learning?
Yeah, yeah.
Yeah, okay, because I used that actually in a PD session that I was giving at my school. So
Yeah,
thank you.
no, I
That was-
think that that's important too. You know, we never give our students a chance to do that, or we don't do that enough.
we don't do that enough, yeah. But I just wanted to thank you for that
Oh,
presentation.
you bet, you bet. I'm glad to hear that.
Okay, well, thank you very much.
You bet. You have a great week coming up here.
Yeah, you too. Take care.
You too.
Bye-bye.
Bye.